Imagine an object the size of a football field hurtling through space at 100,000 miles per hour. It's hollow inside. It's not traveling alone, and it might be watching us right now. Fresh observations from Hawaii's Gemini Observatory North have just revealed something that makes the 3-eye atlas mystery even more profound. The data suggests this interstellar traveler might not be journeying through space alone. Multiple smaller objects appear to be accompanying the primary body, each one following a trajectory that stays remarkably close to 3-eye atlas itself. These aren't faint smudges caused by optical distortion or lens artifacts. We're looking at discrete, confirmed points of light moving together through the void between worlds. Now, as scientists, we exercise extreme caution before drawing conclusions. We exhaust every mundane explanation first. Could these companions simply be fragments? Pieces that broke away from the main nucleus as solar heating increased during its approach? That's certainly possible. But here's what troubles us. If fragmentation were responsible, we would expect to see chaotic dispersion patterns, debris trails spreading outward, irregular tumbling motions. Instead, what we observe appears coherent, stable, and disturbingly organized in its movement. Amateur astronomers worldwide have independently verified this same phenomenon. Stephen Burns posted a time-lapse sequence online showing several luminous points traveling alongside 3-eye atlas. A German observer using the handle Night Monkey identified multiple distinct trajectories, each one maintaining uncanny precision relative to the primary object. Another researcher, Alexander Flum, noticed something equally strange at the 30-second mark of his recording. A brief green flash, a diffuse glow, clearly separate from the main body and definitely not a camera malfunction. That mysterious green coloration represents yet another layer of this enigma. Comets typically appear green because dicarbon molecules, specifically C2, fluoresce under ultraviolet sunlight, but spectroscopic analysis from Chile's Very Large Telescope reveals that 3 Atlas is severely depleted in these carbon chains. They're fragile constructs, essentially dirty snowballs, composed of frozen ices and loosely bound dust particles that fracture easily under solar heating or gravitational stress. A hollow comet racing through space at speeds exceeding 100,000 miles per hour should have torn itself apart long ago from sheer structural instability, yet here it remains completely intact. It even withstood a coronal mass ejection earlier this month, a direct bombardment of charged solar plasma that by all rights should have shredded it into fragments. Something about its internal architecture, its remarkable resilience, refuses to conform to the ordinary laws of thermodynamics we've relied upon for centuries. Now imagine this possibility. What if that hollow nature isn't accidental, but intentional? If an object were deliberately constructed rather than naturally accreted, hollowing out the interior would make perfect engineering sense. It dramatically reduces overall mass while protecting sensitive internal components from radiation and impact damage. It also provides rotational stability that tumbling natural objects never achieve. And if the construction materials were exotic, perhaps elements or compounds beyond our periodic table, that would elegantly explain why the gravitational signature registers so much weaker than expected. To be absolutely clear, this isn't definitive proof of technological origin, but it represents a whisper from the cosmos itself, suggesting that our rigid definitions separating natural from artificial phenomena may require fundamental updating. NASA's Neil Gehrels Swift Observatory has contributed yet another puzzling piece to this mystery. 3-eye Atlas is actively venting water vapor at a distance where conventional comets should remain completely dormant. We're measuring roughly 88 pounds of water per second at 3 astronomical units from the Sun. Most comets don't activate their outgassing until they venture much closer to solar heat. Why is this visitor releasing water so early in its approach? And why does that emission rate remain so unnervingly consistent? The implication becomes unavoidable. Its internal structure, whether hollow or perhaps extensively porous throughout, appears to be channeling thermal energy in ways we've simply never observed before. Meanwhile, those Gemini images continue suggesting that multiple smaller companions travel in synchronized formation as if guided by some invisible organizing principle we don't yet comprehend. If these represent fragments naturally broken away, they demonstrate remarkable stability for debris. But if they're not fragments at all, if we're actually observing discrete entities traveling together with deliberate coordination, then we're witnessing behavior that transcends everything we thought we knew about interstellar debris dynamics. And here we arrive at the truly uncomfortable question we must confront. If these accompanying bodies genuinely represent companions traveling alongside 3I Atlas, could they possibly be probes? Is it conceivable that what we're observing isn't simply one comet, but rather a convoy moving in deliberate interstellar formation, crossing through our solar system for purposes we cannot yet comprehend? As a physicist, my natural instinct pushes me toward resisting sensational conclusions. But I'm also a student of scientific history. Galileo was once instructed to ignore the moons orbiting Jupiter because, according to the established wisdom of his time, they simply couldn't exist. Throughout human history, every single time we've encountered the truly unknown, our first collective reaction has been outright denial. The second reaction, emerging more slowly, has been profound wonder. Right now, we find ourselves suspended in that narrow, uncomfortable space between these two responses. Equally troubling is the conspicuous silence emanating from official channels. NASA, the European Space Agency, even China's Tianwen mission, all possess instruments that were perfectly positioned to gather high-resolution observational data during 3I Atlas's recent close approach to Mars. Yet somehow, the scientific results remain unpublished. The data unquestionably exist. The telescopes functioned correctly, but the information pipeline has gone strangely, inexplicably quiet. This pattern isn't without historical precedent. When Oumuamua entered our solar system back in 2017, certain spectroscopic analyses and radar measurements were withheld from public release for months. When Borisov arrived in 2019, we witnessed the identical delay occurring again. And now, as 3I Atlas sweeps past Mars, history appears to be repeating itself with disturbing consistency. In our current age of instantaneous global communication, silence itself becomes a kind of signal, a message conveyed through conspicuous absence. Perhaps the delay stems from purely bureaucratic causes, a government shutdown, an instrument calibration issue, or simply cautious institutional vetting of extraordinary data before public release. But the coincidence becomes increasingly difficult to ignore. Each time an interstellar visitor challenges our fundamental expectations about how nature operates, the flow of information mysteriously tightens like a valve being gradually closed. To me, as someone who has spent a lifetime in science, this doesn't represent conspiracy in the traditional sense. It represents something more human and more understandable. It's fear. Fear of public misunderstanding. Fear of premature speculation spiraling out of control. Fear of confronting something genuinely extraordinary that doesn't fit comfortably within our existing frameworks. But science simply cannot progress if we permit fear to dictate the boundaries of our curiosity. If this object ultimately proves natural, we will learn profound lessons from studying it. But if it's not natural, if our observations are leading us towards something more significant, then we've stumbled upon a discovery that transcends astronomy itself and touches the very question of whether we're truly alone in this vast cosmic arena. Even statistically, as Loeb himself points out, there simply shouldn't be sufficient rocky material drifting through interstellar space to deliver objects of this magnitude to our solar system through random chance once every decade. The odds fundamentally defy the inventory of known cosmic matter cataloged across our observable universe. The mathematics itself has begun whispering that something else is happening here, something deliberate, or at minimum, something organized by principles we haven't yet grasped. Now ask yourself this profound question. If 3I Atlas genuinely carries multiple accompanying bodies traveling in formation, if these companions aren't merely fragments, but coordinated travelers, what does that reality imply about the universe surrounding us? We've long operated under the assumption that humanity represents the explorer, that we're the ones casting our instruments into cosmic darkness, searching for others. But what if the truth runs deeper? What if we are actually the observed? What if our act of finally looking upward with sophisticated enough technology has allowed us to notice something that's been quietly watching all along? As a theoretical physicist, I don't see this possibility as a crisis of belief requiring denial or fear. I see it as an invitation to fundamentally expand the framework of science itself. Every anomaly carries a message disguised within its strangeness. Every irregularity represents a question we simply haven't yet learned to formulate properly. Very soon now, 3I Atlas will disappear behind our sun's overwhelming glare, temporarily hidden from observation. But when it reemerges in December, the world will be waiting with telescopes realigned and data systems prepared. Information will pour in from observatories spanning every continent, and perhaps if we're extraordinarily fortunate, that institutional silence we've discussed will finally break. Until that moment arrives, we must do what science has always demanded of us throughout history. We must remain patient while data accumulates. We must remain appropriately skeptical of extraordinary claims. And crucially, we must remain intellectually open to possibilities that challenge our comfortable assumptions. The universe operates under absolutely no obligation to conform to our expectations or fit neatly within our existing categories. It simply is what it is, and sometimes, just sometimes, it leaves a mysterious green trail streaking through the darkness to remind us that the greatest discoveries never arrive packaged with convenient answers. They arrive bearing better, more profound questions that push the boundaries of human understanding. Because ultimately, whether 3I Atlas proves to be a fragment of alien geology torn from some distant planetary system, or whether it represents a fragment of alien thought deliberately sent across the void between stars, it carries with it the same precious gift, the opportunity to see ourselves once again as beginners standing at the threshold of cosmic mysteries, and perhaps, just perhaps, the chance to recognize ourselves as participants in a conversation far larger than we ever imagined, written not in human words, but in the elegant motion of celestial bodies dancing through the infinite arena of space and time.